My name is Stephen Gottlieb, and I made up their video for the New York State Regent Algebra 2/Trigonometry exam. At this point, I would just love for you to sit back and view a sample demonstration. That way you get to see a little bit of my teaching style. Suppose you wanted to solve the problem, the absolute value of x minus 1 is equal to 5 minus 2x. You're given some choices. The number 2 and the number 4, say the empty set, number 2 alone, or just the number 4 alone. And this type of problem is probably easiest to work backwards. Look at my choices. I see 2 and 4. So let's try 2 and then 4. X is equal to 2. So I see a bar, and then I see x, which is 2, and then a minus and a 1. The question is, does this equal to 5 minus 2 times x? X, of course, is 2. Well, 2 minus 1 is 1. So is the absolute value of 1 equal to this number minus that number? This number, of course, is 5. That number is 4. 5 minus 4 is 1. The absolute value of 1. Well, if you want the absolute value of any one number, write down that number without a sign. For example, the absolute value of negative 3 is that same number without a sign. Just don't write the sign. But there can only be one number between the bars. If you have two numbers between the bars, you better do the arithmetic in between the bars. Okay, negative 2, and the absolute value is, the absolute value of negative 2 is negative 2 without a sign. Okay, so yes, it did work. So at this point, either this is the answer or that's the answer. It clearly isn't the empty set, and it clearly isn't just the number 4, because 2 worked. So now we're going to try the same thing all over again when x is 4. The absolute value of x, this is how I write x in this problem, the absolute value of x minus 1, does it equal to 5 minus 2 times x? 4 minus 1 is 3. The absolute value is 3. When I write 3 down without a sign, it looks like that. Does it equal to 5 minus 8? The answer in this case, no. 5 minus 2 equals 3. You know that. 5 minus 8 can't equal 3. You have $5 in the bank and somehow you take out 8, you don't have 3 left. If it does, keep taking out. It's negative 3. So no. So the only one that worked was 2, but not 4. So it turns out that x equals 2 is the answer. Okay. We really should, however, know how to do such a problem without working backwards. And why don't we actually solve the problem? But since it's a timed exam, when you do come upon this problem, whether you know how to do it or not, working backwards will probably be quicker. Now, we need to understand the absolute value function. It's a piecewise function. Sometimes the absolute value of x minus 1 equals one thing, sometimes it equals another. If what goes in here is bigger than 0, add 1 to both sides to solve for x. If x is bigger than 0 plus 1, which is 1. If x is bigger than 1, this is positive. I know, I just solved it. When is x minus 1 positive? When x is bigger than 1. If what's in between those bars is positive, in this case, x is bigger than 1. What's in between these bars will be positive, and then you get back exactly what's in between the bars. Now, let's look at absolute value of negative numbers. I claim you also get back the same number you put in the bars with a negative in front. Fair enough, it equals 7, but I don't really care about that. If you plug in a negative number, you get that same negative number back, the negative in front. The absolute value of negative 13 is, believe it or not, negative 13 with a negative in front. If what's in here is negative, well, when is x minus 1 negative? Add 1 to both sides. When x is less than 1. If x is less than 1, then what's in here is negative. And of course that's true. If you have less than $1 and you spend $1, if you have less than $1 in the bank and you take out $1, you will be negative. And if you're negative, you're not going to get back x minus 1, but rather negative x minus 1. And you can think of x minus 1 as 1 times x minus 1. In fact, negative 1 times x minus 1. Now, I love positive quantities to write first. Negative 1 times negative 1 is positive 1, or just 1. And negative 1 times x is negative x. When x is less than 1, x minus 1 will be negative. And if x minus 1 is negative, the absolute value of x minus 1 will be negative x minus 1, also known as 1 minus x. Now, if x minus 1 is 0, that is if x is 1, 1 minus 1 is 0, the absolute value of 0 is 0. Well, 1 minus 1 is 0. I can sneak the equal sign in there. If x is equal to 1, the absolute value of x minus 1 is x minus 1. They're both 0. For the record, I could have put the equal sign there, because if x is 1, the absolute value is 0. Certainly does equal to 1 minus 1, which is 0. Okay, so now that we have a command or understanding of what the absolute value of x minus 1 equals, what we need to do is solve this original problem. There are two cases. Case 1 is where x is bigger than 1. Case 2 is where x is bigger than or equal to 1. And here x is less than 1. So the absolute, if x is bigger than or equal to 1, the absolute value of x minus 1 is x minus 1. X minus 1 is equal to the right-hand side. 5 minus 2x. Whenever I talk about left and right sides, I mean with respect to the equal sign. The left side has 1x, the right side has negative 2x's. I like to bring the x's to the side that has the most, the left side. So I'm going to undo taking away 2x's by adding 2x's to both sides. The right side is vanished. Well, if all the x's are on the left side now, 3 x's, I want the numbers on the right side. So the undo taking away 1, I'll add 1. And you really should make sure this equal sign is right. A lot of you don't even write it, and probably almost 100% of you don't look to see if they're the same. You really need to get into that habit. 3 times a number is 6. The number is 2. Now this may have to be rejected. Oh, it's bigger than 1. The answer we got, 2, the answer we got for x, is actually bigger than or equal to 1. 2, yeah, is bigger than or equal to 1. So we can keep that answer. If we did all this work correctly and we got x equals negative 5, negative 5 isn't bigger than or equal to 1, have to reject it. Now x is less than 1. Okay? So the absolute value of x minus 1, well, if x is less than 1, equals 1 minus x. Okay, 1 minus x. And that equals to the right-hand side. Is it understood 1 here? The right side has negative 2x's, the left side negative 1x's. The left side has more x's, once again. So I'm going to add 2x's to for both sides. The left side by design, on the right side, excuse me, by design, it canceled. The left side. You want to do -1 plus 2, fine, you really should get 1. I'd rather do 2 minus 1. Okay, but I don't want the 1 here. I don't want this 1 here. So take it away. When all the numbers are on the other side. So I get x equals 4. And now, you start thinking, oh yeah, that choice said 2 and 4. That must be the right one. No, because this work is only correct if x is less than 1. X is 4. You have to reject this one. So once again, the correct choice was the one that only included the number 2. This completes the demonstration for the Algebra 2 Trigonometry New York State Region exam. I want to thank you for viewing my sample demonstration. Most of all, I'd like to wish you great success on your upcoming region exam. Thank you.